learners. Now we are going to understand the instruction of the activity for experiment number 4, angle bisector theorem and its converse. For that, visit the lab URL under lab URL class 9. Under that, experiment number 4, angle bisector theorem. So this, why if you click it, you will be get viewed the two statements. One is for angle bisector theorem and converse of angle bisector theorem. And the courtesy of this article is from John Sweeney. The author is John Sweeney. We are taking his work. Now coming to the theorem statement. The theorem statement states us that if a point is on the bisector of an angle, then it is equidistant from the side of the angle. Okay. So if you look at this point, and this is made as a slider, so if you move the point from one place to another place on the bisector, then you can observe that the distance between the point on the bisector to the side of the angle is equal. The word equidistant means that the sides are equal, right? So I suggest you to take a screenshot of the same by making it in full screen mode. Just take a screenshot of the same and paste it in the observation. So the thing that is to be noted is you have to adjust the slider not to use the default value while you are making it for screenshot. The second thing is the converse of the angle bisector theorem. There is an option given inside. So click on the converse of angle bisector theorem. The converse of the angle bisector theorem is the same, just the opposite of it. So if you observe clearly, you can see that if a point is equidistant from the sides of the angle, that is in the reverse of the angle bisector theorem is the converse. So if a point is equidistant from the side of the angle, then the point is on the bisector of the angle. So here the point on the bisector of the angle is with 4.55 distance from the sides, and it is clearly mentioned that since the distance is equal from both of the sides, then the point BD is on the bisector of an angle. Okay, so the bisector of the angle is 29.68. The angle is divided. Okay, so here there is yet another point which is given. If you try to locate it with equidistant, okay, so look at this. If the point is on some other place, you can clearly witness that the point is not on the bisector. Even if it is on the bisector, the distance must be equal. As per the converse of the BPT, the distance must be equal. Only if the distance are equal, then you can say that the point is on the bisector. So here you can adjust the points as it is given. If you adjust the point and locate it properly, then the point will be on the bisector. Okay, so you have to take a screenshot either with the case that the point is on the bisector or not on the bisector comparative to M. Okay, but as far as D is concerned, as far as the point D is concerned, it will be equal. By default, it will be equal to, so you can adjust it and take a screenshot. Okay, so here there is a code given. Km will only be equal to Cm, this 2 points. Okay, Km will be equal to Cm if M is on the line segment BD. Okay, line segment BD. Okay, HD is equal to DJ. HD, where is the point? HG, okay, yes, HD is equal to DJ because D is on the line segment BD bar. Okay, so this is what the observation that is to be taken. After taking the observation, you can start moving to the writing part. So I'll just give you the instructions for the writing part. So I hope the whiteboard is visible. So we have to start writing it. As usual, your experiment will be with all the 5 basic things. One is aim. So the aim of the experiment is to verify ABT. Write it in full form and abbreviate it with bracket, angle bisector theorem and its converse experimentally. This is your aim. So the materials required will be, this is made by an virtual portal called GeoGebra. Next you have to write the theorem statement, both ABT as well as its converse separately. Okay, ABT and converse separately. Then you can write the procedure. So in procedure, the 5 points is to be included, not more than that. Okay, first is draw an angle ABC. Okay, draw an angle ABC. So this is just an overview. You can come out with your own sentences on this. Okay, bisect angle B. Plot point D on the bisector. So this is for angle bisector theorem. Similarly, you have to write it for converse also. Plot point D on the bisector. Connect the sides of angle. Connect the sides of angle from D and mark it E and F. Okay, after making it, we observe ED is equal to FD. Okay, hence the ABT theorem is verified. Similarly, do it for converse with the same set of statement. Only the difference is you have to first draw the line, and after checking the line it is equal, then we will conclude that the point D is on the bisector of the angle B. Okay, so that is the difference. Only 1 point is the difference in the procedure points. Then you have to write the observation. Just stick the screenshot. 2 screenshot has to be sticked. One is for angle bisector and other is for its converse. Okay, so the last point is conclusion. So the conclusion, you can say write it as, thus we verify ABT and its converse experimentally. Okay, hope up to this you can finish it off. Okay, so hope the experiment is very clear with the understanding. If you still have any if you need still any clarification, you can write an mail to me. I'll definitely reply to it. Thank you all.